pleasure to introduce Mr. Brett Connell, co-founder of Truda Environmental Solutions. I had the pleasure of meeting him during the vendor breakout after the Tennessee Water Resources Symposium at Montgomery Bell a few months ago. Shamelessly, I was just looking for swag because I don't know a whole lot about stream surveying. I'm on the wastewater side of things, but Brett kindly approached me and just kind of gave me his little pitch, and within 30 seconds into the 5 minutes of the conversation, I was blown away with this product and service he provides. So hence me recommending him for a technical training. So with that said, Mr. Connell has 20 years of experience in water resources and fisheries biology. He has led over 1,400 miles of projects across the United States, focusing on his innovative technologies for stream assessment and restoration. Brett holds a master's in science and biosystems engineering technology from the University of Tennessee, go Vols, obligatory, and a bachelor's in science and environmental science from the University of Toledo, and an associate's in applied science and fisheries management and aquaculture from Hocking College. And with that said, I'm going to turn it over to Brett.
Awesome. Well, thank you for the introduction. And yeah, the Tennessee Water Resource Symposium's been very great for making connections. So I was glad to have met you there. And again, I appreciate this opportunity. So with that, as you kind of said, fisheries management was a big part of my early career. And I worked, in Oregon, Idaho, Utah, Colorado, all over the West. And a lot of my fisheries work involved habitat monitoring, taking measurements and whatnot. And then my last job in Utah with Utah DNR was actually a lot of stream restoration. And so when I called the University of Tennessee looking for a graduate position, they kind of called me back, and it was Dr. Ayers in the biosystems engineering department. And he said, what do you feel about putting a camera on a kayak and, using georeferenced video to do environmental assessments going down the stream? And I was just like, sign me up. And so I was literally on a plane 5 days later, and that's where all this kind of started back in 2010. And this was literally my thesis that we turned into a company. And so that's kind of the early career aspect of this. And there's a big data gap between landscape modeling, which I assume a lot of you are familiar with, and then the terrestrial, like when I'm out there stretching a tape across the river, doing pebble counts, measuring pool riffle run. Like, you can get a whole lot of great information in a small area, but a lot of that's just centered in one little position. And traditionally we extrapolate from miles upstream and downstream. And then you have landscape modeling, which is obviously very, very powerful, but sometimes there's QA/QC that needs to be done. And so that's kind of where high definition stream focuses on, is this intermediate area where we can find out, what is the problem, where is the problem, how far downstream does that problem exist? And then being able to kind of compare that with meter resolution. And so when we go and map 250 miles of a watershed 1 year and we go back 5 or 10 years later, we can literally show like where habitat's improving or declining based on habitat use, or based on land use, based on restoration practices that are being done. And so that's kind of the main point. This is me back in grad school with Dr. Ayers. And so back then, again, it was just left and right video. Since then, we've added the forward video and underwater video, and basically just to get this 360 view of what's going on in the water. And the whole point is to turn on that equipment and go. Whenever underwater video isn't available, whether it's depths or turbidity, we have the side scan sonar unit. I'm not sure if any of you are familiar with it, but that technology keeps getting better and better every year. And the river could look like a milkshake as far as how dark it is, but the side scan sonar unit just pulls up beautiful imagery of the bottom of it. You can see different types of substrate types, embeddedness levels. You can literally, they use side scan sonars to count sturgeon down here in Florida. And then we have an 80 CP when discharge measurements are needed, which we've actually used that on the Harpeth River and a few other bodies of water within Tennessee already. We have the water quality sensor that's continuously running, just getting your basic water quality measurements. And then there's also the opportunity to do water grab samples, and whether that's for, E. coli or additional laboratory water quality testing, we're able to do eDNA filters, and the list kind of goes on of the additional types of grab samples we're able to get. And the whole point is, we can cover 20 miles in a day now, and all of that data that we collect in the field is geo-referenced. Every second of data has an associated latitude, longitude, surface water elevation, substrate elevation that gives you depth. And so you're just able to start building this big database of, instead of just a thin blue line going down a river, it's a whole bunch of GPS points that are just very in-depth data. And so I'm down here in Florida. That's where I live. Jim Parham, he's up in Nashville. And I assume most of you, I don't know if people are still working from home or not, but whether I'm giving a presentation to people in Alaska or Maine, California, it doesn't matter. Like, we're able to see, this is a Hurricane Creek right now, that the survey we did April 21st, 2023. And we have this video archive that we can go back and revisit anytime that we need to. And I also have to say that if the video looks a little herky-jerky, it's just because we're on the video conference. But all of our video is shot in 1080p video. It's very, very crystal clear on my end. And so the different types of platforms we have, the thesis and most of the mileage was probably done by kayak. But then we started getting into stormwater mapping and going up higher into the watershed where you could not do a kayak. And so our backpack method was a lot. And then we started going to bigger rivers. A lot of the work we do is for hydropower companies. And we've literally done, I remember I think the biggest was the Coosa River at 40,000 CFS. And so, whether we're surveying at the very top of the watershed or all the way down to the very bottom, we can, have that continuous line of data with the equipment that we collect. When there's areas that we can't go into, we have tablets, we've used drones, and then we also have an autonomous boat when we're dealing with water. A lot of our lake surveys, like pond bathymetry before and after, dredging, or even if there's mining ponds that have toxic water that I don't want to go ahead and get in, we can just put that boat in and go collect that information. This is actually Falling Water River from a project that we completed with TDEC, just to kind of show the water quality sensor. And as we're coming down river, we're within a certain class of specific conductivity. But then when we got to Pigeons Roost Creek, we can see that specific conductivity spiked. And then when you get back into the main channel, you can actually see that that small tributary literally changed the characteristics of that entire main channel. Just some pretty eye-opening material. And these are the Eureka Mana 35 is what we own right now. We're not beholden to any brand or whatsoever. If you guys prefer in situ, or the list goes on of all the different brands, we're able to geo-reference that information. Just wanted to put that out there. The first main deliverable when we deliver video, this is actually a project we did for the National Park Service on the Chattahoochee River. We deliver this assembled video file, and when we send it to you guys, it actually has the GIS information embedded in the video. So whether you use ArcGIS or QGIS, right here, I can see, I know that there's a bridge. And so we can just go ahead and click, and then boom, we're able to move, anywhere within the watershed that we want to see what's going on where. And it doesn't matter whether you use QGIS or ArcGIS, we have that GIS data embedded in the video when we deliver it. This right here is kind of the brains of it. So after we go and do a survey, I'm watching this video in the lab. And so if I see a pipe on the left side of the river, actually, that wasn't supposed to happen. If I see a pipe on the left side of the river, the video will literally pause, and then I can go ahead and say, well, that pipe is on the left bank or the right bank, or it's affecting both banks. And then I can also give a score of, is that pipe affecting the stream bank, or is that pipe about to fail, or the list goes on of what other information you want to tag onto that. And then you'll just go ahead and the video keep on playing, and you can continue finding other points that are within that watershed. And so just to kind of reiterate, whether we're doing continuous data or we're doing point data, this is actually a project we did in Cleveland, Tennessee. We mapped out their stormwater, and every second of video is has the associated date and time within the database. And then you have the latitude and longitude that matches the map. And then we have the whole post-processing and also automatic data that's added to that individual GPS point. And so this is, it just looks like numbers right now, but this is actually the output for the stream corridor assessment that we did for the city of Cleveland, Tennessee. And 5, 10 years from now, if they wanted to, apply a different index, whether it was the stream corridor assessment, rapid geomorphic assessment, the list kind of goes on of all the different assessments out there. But we have that video archive. And so we can go back and rewatch the video and apply the new standards. And then we'll have a comparable data set to any future surveys that we do. And this is just a zoomed out view of the city of Cleveland, for instance, and we'll zoom in and you can see, we're able to see both left and right riparian. You can see left and right stream bank and the stream bed. We're able to map out all the individual manhole covers, outfalls, fish barriers, cows, tires, trash. The list kind of goes on, and it almost seems like every project that we go do, we find a new point information that we need to, add to the database of, all the information that we deliver to somebody. A lot of times, whether it's a stormwater project or a mining reclamation project or a disaster recovery project, the list kind of goes on of all the different points you can put in there. And so then we'll take all that point information and the continuous information, and then we can start prioritizing, okay, well, where within the Cleveland MS4, where can we spend the least amount of money to have the highest amount of ecological lift? It's all about like decision making, and when you can prioritize your decision making to pick the lowest hanging fruit, that's going to be better off for the watershed. If you have a budget of X dollars, I know exactly where I need to spend that money to have the biggest bang for the buck. And then you also have, 10 years, so after you go and do that restoration, we can go ahead and do another survey 5, 10 years down the road and actually show, did it actually improve that area? And if so, how far downstream did it improve that area? Or did it get worse? Because there's a lot of restoration done in the United States that with the level of monitoring is almost zero. And that's always kind of baffled me. But either way, I'm going to touch, we've done a lot of work on the Duck River just to kind of summarize all the different types of data that we've gathered and are able to gather. And so it started with TDEC. We actually did 155 miles of the Duck River. Two guys did that over 10 days, and we also collected cross sections every single mile, as well as into some of the tributaries. And that was for TMDL modeling, was the original purpose of us going on there. But even though we only delivered bathymetric information for that project, we had all of our video and other sensors on. And so we're still sitting on a whole bunch of video, stream bank information, a whole bunch of river stream corridor information from 2016 and 2017. And we've actually done, as you guys are about to see, about 12 different projects on the Duck River. We've been working there for a while. And so just the most basic data is depth data. And so here's all the georeference depth data. And then you're able to, look at that over the whole big picture, and you can start modeling, well, during a drought or during a flood, where are we going to have the biggest impacts? And then, so when it comes to determining habitat types, and so you have pool, riffle, run, we will automatically delineate that based on, depth, elevation, and slope, but then we'll go ahead and do QA/QC ourselves and make sure, is what our algorithm's calling a riffle actually a riffle and whatnot. And so there is QA/QC going on with a lot of our data. And then we're able to link that with discharge information that works with TMDLs, MS4 stormwater. The list kind of goes on. And I really like this image right here from the Duck River. And then you can start literally implementing, what municipalities are where, how much water are they pulling out, how much is going back in, what species of fish, what species of mussels are where. And so when it comes time for a drought, which is inevitable in the Duck River with this high use, we can know, okay, well, we got to start limiting withdrawal in certain areas because there's T&E species here. At least we know what types of impacts are going to happen at what levels of drought and what levels of flood. And here's just a quick little image of the cross sections that we're able to gather. It's literally as easy as pulling over to the side of the river and going across and then continuing on downstream. The main difference is the equipment that we have on the boat. And we usually just run a Trimble R12 running RTX, which is a satellite-based GPS correction. It gets us very, very precise information, very precise measurements. And then if we also, as you guys are going to see in some of these other projects, we actually need even more precise. And so again, it's just all about the equipment that we put on there. So we did a whole bunch of additional cross sections in the so in the city of Lewisburg, their drinking water area, and then we also did the Columbia Power and Water Reservoir capacity. So we were doing cross sections, in the river leading up to their impoundment, and then we did more within the impoundment. And then so we actually took that data and I believe this is the city of Columbia. But either way, there's more drinking intakes going in, and so they kind of used our longitudinal and old data to figure out, all right, we have two different sites of a potential intake. Let's go ahead and go get very precise measurements. And so we ran that Trimble R12 and got very precise measurements in those two locations. They used that information, and then there was also the Maury County where they had, I believe this is about a mile long section on the Duck River where they had different segments where they needed different densities of cross sections. We went ahead and collected all that information, and because this is a drinking water placement, they needed an extra level of precision for terrestrial data, the topography. And so hopefully, let's see if this works. It's just a little bit of a visualization of the bathymetric data that we collected being combined with the terrestrial data. And this right here, well, most of the time when we're doing our surveys, we don't have boat-mounted LiDAR. The reason we did that was just limitations that they we're not able to fly a drone at that location, and so that's why we did boat mounted. But either way, you can just see that data, that point cloud is just absolutely beautiful. And so when it comes to flood access into the riparian area, either way, that's a whole lot of information, and looks great. When it comes to the topography surveys we're doing, there's multiple different uses. This is a project we did for the Alabama Power Company, where they were actually doing a drawdown on the reservoir downstream, and they needed to assess how much exposed habitat was going to be for threatened and endangered snail species. And so we went out and collected cross sections. They loaded the data into HEC-RAS and did their modeling for that. We're able to, again, this is some output from the ADCP that we run, and I believe, this is actually from the Harpeth River survey that we did. I think within like 2 or 3 years ago, we did this survey, and that was for a water treatment facility going on the Harpeth River. And so they had to do Qual2K modeling. And so we went and collected discharge measurements at needed locations. And then we also did channel shading. And so those are just visualizations of where those channel shading measurements were taken and loaded into the model for the Qual2K. And then we also have channel dimensions that were used for that. And again, here's some examples of the bottom imagery. We're able to see, very rough, medium, and then you have smooth areas. And then you're able to, throw that into a table and start showing, what percentage throughout this whole, Duck River watershed is what types of substrate. And that can play into, again, the Qual2K modeling for the roughness factor. And then you also have, TNE, habitat suitability modeling, which I'll get into here in a little bit. And this is just some more examples of that side scan sonar imagery. And when conditions allow, we'll use a drop down camera to make sure, we get some actual QA/QC, make sure we're seeing what we're seeing. And this is just a good example of a project we did for Alabama Power back in 2018, where you can see a whole bunch of fine substrate in this area and very little bedrock. And then we go back, so that was in 2018, and then we resurveyed in 2021, and we're able to see a whole lot more exposed, substrate that's suitable for the mussel species that they're literally managing for. And so all those fine substrates are getting lifted out. And we just got the PO to go and do this survey again. And so we're going to pretty soon have imagery from 2026. And I'm hoping that even more fine sediments are cleared out. But as of right now, I have no idea. So I'm excited to do that project this summer. And then, so you're able to see that bottom imagery, but this kind of shows just some of the classes of the different types of substrate. You kind of have to look very close to see where it's kind of changed within that. But also because it's GIS information, we know what percentages of fines and gravel and boulder and cobble, we have that percentage of different types of classes throughout this stretch. And you're able to start tracking, where is it improving or where is it declining? And so this is one big project we did. This was in May of 2023 is when we collected all the data, but this is pretty much our first watershed scale assessment where there's 250 miles of river. But before that, just the Alabama Department of Labor, they deal with a lot of mining issues. And so each one of these little polygons is called a problem area description. And so they knew that there were old mining claims in these areas, and they know that they have water quality issues, but they had no idea which one was the worst one, or even like where within that sub watershed is the worst area. Where's the actual point source of pollution that we can, start addressing some of that stuff. And so that was the problem for the abandoned mine land manager of Alabama. He came to us and we mapped out all 250 miles of this entire watershed. And so there's 240 major confluences where we took water quality measurements in the main stem as well as the tributary. But then we also took many additional water quality samples at, if there was an acid mine drainage seep coming out of the, side of the river, we'd literally take a measurement downstream and take another one upstream so you could start calculating like how big of an impact was this individual seep having on the tributary. And we have that information through all 250 miles of this watershed. And the data, as you're about to see, is just spectacular. Just kind of touching on the data that we got, I brought up the stream corridor assessment before. So after we watch that, after we go and collect the video, we'll score, both riparian zones, both stream banks and the stream bed, as well as discrete features. Here's a visualization of those 250 miles. We'll just go ahead and zoom into this area, and you can see there's some red. Well, what's going on? Well, we know exactly what video file. We'll go ahead and click on it. And so, again, I'm down here in Florida. You guys are up in Tennessee, but we're seeing the impacts that are going on in this watershed. And you also have to keep in mind this project was funded to solve acid mine drainage. This is an abandoned mine land funded project, but here I am documenting obvious stormwater problems. They've been throwing down riprap, trying to prevent further erosion. And either way, you can see that there's been a ton of sediment that's been swept out. There's infrastructure that's exposed. And so either way, there's many different issues that can affect a stream. And so we don't just go out and only collect data that's acid mine drainage. We turn on our equipment and we document everything. Excuse me real quick.
This one's messy? Yeah. Okay.
Nice.
I will take it from you.
All right.
Do you need more?
I'm pretty sure you got your microphone on. I got my kids at home too, so I get it. So here's the when you have all this information, there's numerous different ways to look at it. So we can look at it, throughout the whole watershed. How does the riparian compare to the stream banks, compare to the stream bed? And then we'll break it down even further. We can look at subwatersheds, and then we can even look at the problem area descriptions. And so now the state of Alabama, for this Hurricane Creek watershed, has a prioritized list using the stream corridor assessment at this point, which are the worst problem area descriptions. And so we can start ranking them. This kind of is going into all the different types of discrete points that we collected. And so whether that's acid mine drainage, perched culverts, that's me right there. I'm 6'3". This is a giant twisted metal pile of garbage. I'm pretty sure it was a radio tower that got twisted up, but either way, the river that I was surveying went directly underneath it. And then there's many different types of discrete points. And so if you were only interested in infrastructure issues within this watershed, well, we'll go ahead and highlight all of the infrastructure discrete points. And well, here we go. Here's a road. And pretty obvious this road has been washed out. It's very obvious that there's plenty of fresh sediment that's continuously getting flushed into this, into the Hurricane Creek watershed. And then you have, additional infrastructure that's exposed right here. And a lot of times it's just, this would not have been documented if we didn't turn on our equipment and go the distance. And so we know what everything looks like right now. This is, May 7th, 2023. And then if reclamation is done here, any type of restoration, we'll be able to go back and show, 5-10 years, like how much has it improved? How big of an impact was it having downstream? Here's another good one, or just trash, because there's a lot of different types of restoration, whether you're doing a full-on stream bank restoration where you need excavators, whether you're doing willow planting, or maybe it's just a trash pickup. And so a lot of stuff that can be done in a watershed can be done by volunteers. And so now I know exactly where to send volunteers if they want to go pick up garbage in the Hurricane Creek watershed. And as you can see by the extent and amount of this trash, it's probably a good idea to involve law enforcement, because this is just a very active dump site. And this is the worst I've ever seen in my life. It was pretty eye-opening to see it. It was an active dump site. But either way, we know what it looks like on May 4th, 2023. We have this documented, and hopefully it's been addressed and looks better now. So
Hey, Brett, I'm just going to jump in. We did have a question in the chat. So this looks a lot like Google Street View, only maybe it'd be called Stream View. Is Google interested in getting this information and data from you?
So we call it true to stream view. So you're right on track right there. We toyed, I think back in 2018, with running a Google camera on one of our boats going downstream. The main problem is, one, when we use our multiple camera setup and go collect data and then assemble our video on one flat screen, you can see left, right, forward, down, underwater. You can see everything on one screen. But when you use 360 video, you're either looking at right bank or you're either looking at left bank. Then you also have, it's a spherical lens, and so you have distorted imagery. There's many reasons. And then another thing is you can't, like, that's Google's information, and so we're not able to actually tag additional information on to anything collected by Google. They want that information. And so hopefully that answers your question. Does that work? Good. Well, just let me know if it doesn't. But
Well, it looks like we got a thumbs up on that one.
Perfect. I appreciate the feedback. I'm not able to see. Thank you. So there's multiple levels of prioritization that was done for the state of Alabama. The first part was the stream corridor assessment that I just went over. Then there's the stream channel modification category that we came up with. It's called iron oxidizing bacteria. And so you guys are going to see some imagery of, it's basically brown water. Where's there high dissolved solids in this water that starts precipitating out. And we basically did it in three categories. It was either not present, moderate, or bad. Very, very easy to see. And so here's the red. We'll just go ahead and go to this one area, and boom, we're able to see what conditions were. This was on May 6th. And so we're using this right now to prioritize where future actions are taken. And so if there is reclamation done here and we come back 5-10 years from now, we should be able to see that there's less precipitate and there's less orange, and that there's more clear and fresher water coming downstream. The water quality assessment that we did. So as I'm walking upstream with the video running, we came to a confluence. We would stop. We'd take 3 replicate measurements in the tributary, and then 3 replicate measurements in the main stem. We'd collect those, and then we just go on and keep on hiking. We'd do it again at this confluence, and then we did it again at this confluence. And then we actually had 2 to 3 teams running every single day. And so one of the other teams would come in here and start at this tributary, at the bottom of this tributary, and then they would go ahead and spiderweb up into their sub watershed, and I would continue on this main stem. And we just did that. It was literally all 250 miles we completed in 2.5 weeks with our crews. And that was a lot of hiking around. It was a lot of beautiful land and a lot of acid mine drainage. So it was an experience. Here's just an example of all 777 water quality measurements that we took. There was a lot of beautiful water that we got to hike through, and then there was a lot of bad, and it was just very eye-opening. You can even see the main stem of the Hurricane Creek back here was just absolutely crystal clear and beautiful, and then you have this guy coming in just dumping massive amounts of sediment. And if you look at the main stem survey, you can actually see like how far downstream does this impact go, and the data looks great. And so with those water quality measurements, obviously right around neutral is the majority of all the measurements. And then you have these outliers down here at the bottom. And so let's just go ahead and map those out. And we can actually see the lowest measurement we got was 3.17. Most of the bad measurements were taken in this North Fork watershed right here. And so you saw before with the stream corridor assessment, we can prioritize by, the physical habitat of the stream. And now we can prioritize by the actual water quality. Then we also prioritize by what do you call it? The iron oxidizing bacteria. So the orange colored water. And so those were the different levels of prioritizations that we're going to do. We'll go over them one more time. A big thing too, like when we went and did this survey, is a lot of like reclamation in the Hurricane Creek watershed literally started probably in the late 70s and early 80s, that reclamation projects were happening in this watershed. And so we're going to be able to use the data we collected in 2023 to kind of rate, what types of treatments done where were having the best amount of impact, because we saw a lot of reclamation that was done and the water quality was actually very good. It was kind of surprising. And so we could see, which practices and areas were better and which ones were not better and we're still having bad impacts. And so again, we see what was done before, we're able to prioritize what we do next, and then we're going to have this baseline condition to compare future assessments and show with meter resolution where is it improving and where is it declining. And that kind of gives you a return on investment for all the reclamation money that's going to be spent throughout there. So here's the watershed as a whole. Again, we have corridor function being prioritized. Then you can see all the point impacts. And so these are going to be, cows, trash, outfalls, acid mine drainage seeps. And then you have iron oxidizing bacteria, that's your brown water. And then you have water quality pH. And so we took those 4 different outputs that we got from the high definition stream survey and combined those into one. That's what the Alabama Department of Workforce wanted. And so now they have it. Each catchment basin within this watershed has been prioritized. So this number 1, that's the worst. So that's your lowest hanging fruit. Where can they go and spend money and have the biggest amount of impact to water quality? And just to kind of reiterate that the True to Stream view video, that's the first deliverable. Then we have all the GIS data that's delivered. And I remember when we first started, we were delivering kind of just the raw data and let GIS experts within TDEC or anywhere else, use the data. But then we found that that's not always the best. A lot of people aren't as skilled in GIS as some of you may be. And so we've just found out that we make sure that we answer very specific questions with some of these shape files that we send over, whether it's, stormwater related, acid mine drainage related, disaster related. And then we put all that together, put out the report. And I'm going to jump onto a few other aspects that high definition stream survey is applied to. Habitat suitability being a big one. A lot of the work we've done, whether you're dealing with trout, whether you're dealing with hellbenders, whether it's mussel species, there's there's questions. And so where are they now? Where do we protect, restore, and reintroduce? Each one of those questions require a data set, but that data needs to be used in different ways. And just kind of an example, this is a project we did on the Upper Delaware River, where that project was focused on recreational suitability as well as trout habitat suitability. And so not only can we do different species of trout, but we can actually do different life stages of those different species of trout. And all those, all that information is based on peer-reviewed published information. We just pull the data out from high definition stream survey and we can prioritize where's the most suitable habitat for brown trout, or, where's the worst area? Because if this area right here is bad and we want to make sure that there's nothing but continuous, well, we can go ahead and figure out what types of restoration we need to do in these bad areas. And so again, it just all depends on, your goals of managing that river. This is back on the Chattahoochee River, the project we did for the National Park Service that had a very high recreational aspect to it. And so they had, different types of fishing. And so whether it's wading fishing or boat fishing, and then even going more in depth, you got whitewater kayaking, and then you also have tubing for, 5-year-olds. And so there's different types of recreation being done on the Chattahoochee River at different areas. And so they needed to make sure that the types of access that they had for wading fishermen, or the types of access they had for tubing, or the types of access they had for whitewater kayaking, that the access points match the recreational type going on. And if they needed to put on signs that say, hey, you know, fifth graders tubing down the river at this point need to get out because there's about to be some hairy whitewater. And so either way, they can just really start prioritizing what types of recreation are done where and what actions they need to do to, you know, fulfill their duty as the National Park Service. This right here, this is back on the Upper Delaware. And again, another just the beauty of high definition stream survey. We went and did this. This was for recreational and for trout habitat suitability. And so we went and did the survey, and about 3 months after, when we're, you know, watching the video, doing our assessments and putting the report together, they called up and asked, hey, do you guys know what Japanese knotweed looks like? And we had zero clue what Japanese knotweed looks like. And it coincidentally was in bloom, and it's this plant on the shoreline with big white flowers. And throughout that whole watershed, it was very obvious, where is there this invasive Japanese knotweed? And so rather than having to go out back into the field, we literally just watched the video one more time over. And I showed yes or no, is there Japanese knotweed present or not? And you can zoom in and see the detail for both left and right bank. Is it present or is it not? And so we have the video visualization, so you can see where it is, what it looks like, how bad is it, how dense is it. You can look at the map and see where is the presence absence, but then you can also go into the underlying data and show, you know, how many meters or what percentage of the Upper Delaware River had this impact. And there's many dollars being spent on management of this invasive species. So whether they're doing mechanical control, chemical control, or biological, they're throwing the kitchen sink at it, trying to figure out what's the best method to, you know, one, control the spread of this plant, let alone eradicate it. And so there's a lot of money being spent on that. When we go and do this survey, and in another 5 years, we'll be able to show, you know, where is there, you know, what management methods are working better, or where are they wasting their money, or where are they not? And so we can really prioritize, again, where that restoration is done and what types of restoration. And this kind of gets just to the core of high definition stream survey. And so we'll go and do a river survey, and whether you're using that data for MS4 stormwater, whether you're dealing with infrastructure, whether you need to do water quantity, water quality issues, you have the threatened and endangered species, or even just sport fish that aren't endangered, but you want to manage for a better smallmouth bass fishery. Like, the list goes on of the types of, you know, habitat suitability you can do. And what I really love about high definition stream surveys is, you know, the stoplight fashion: green is good, yellow's okay, red is bad. There's a lot of stakeholders out there that want to have clean water. They want to do what they can, but they might not have the education or experience that we all have in water resources. And so this just really easily shows, where is it good, where is it bad, what types of, you know, where is their property, or practices they're doing on their property impacting the river. And so we can show, is it good, is it bad? Then we can put them in the river and show, you know, why is it good, why is it bad? And it's just very transparent. It's transparent for stakeholders, and it's also transparent for a lot of the, you know, I'm sure there's managers at TDEC that don't get out on the river to actually physically see what is going on the river that they're making decisions on. And so having this baseline inventory, being able to take a tour of a river to see, you know, what were the conditions like in the past in this exact area, and bam, you have that video archive and all the underlying data with it. And so with that, I'll go ahead and wrap this up.